Hello students. So in this video we will study the practical problems on union and intersection of the two sets. Okay, we have studied the definitions, the formulas and some problems on union of the two sets, intersection of the two sets, complement of a set and the subtraction A minus B, B minus C, C minus C and so on, the subtraction of the two sets and the related properties and some problems on these concepts. Now moving on, in this video we will study the practical problems related to the union and intersection of the two sets. Okay, so let us see some of the formulas. Right, first one is if A and B are the any two sets, if A and B are the any two sets and A intersection B is a phi, A intersection B is a phi, indicating that the A and B are disjoint sets. What is the definition? The definition is if A intersection B is phi, then A and B are what they are disjoint. They are disjoint sets. Remember that if A intersection B is a null set phi, then we say that A and B have no common elements. Then we say that A and B are disjoint sets. A and B are the disjoint sets. Okay, A and B are disjoint sets. Next, if A and B are disjoint sets, if A intersection B is null set, that is if there are no common elements exist in both the sets A and B, then the total number of the elements n of A union B, then the total number of elements of n of A union B is always equals to n of A plus n of B, number of elements of the set A plus number of elements of the set B, number of elements of the set A plus number of elements of the set B. Okay, remember this. Second one, in general, if A and B are the finite sets, if A and B are the finite sets, okay, so this property will be defined on the finite sets A and B. If A and B are the finite sets, so then generally I can say that the total number of elements n of A union B is always equals to n of A plus n of B minus n of A intersection B. The total elements of the set A and the total elements of the set B are added, and then the total elements of the A intersection B are subtracted from this sum to get the total number of the elements of the A union B, n of A union B. I repeat, n of A union B is always equals to n of A plus n of B minus n of A intersection B, minus n of A intersection B. So moving on, if A, B, C, choosing A, B, C, this is for two sets and there are three sets are available. If three sets are available, if A, B and C are the any three finite sets, if A, B and C are the finite sets, then I can say that n of A union B union C is always equals to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus, remember plus n of A intersection B intersection C, A intersection B intersection C. So by remembering these three formulas, these are the very important formulas required, which helps to solve the next upcoming problems. Okay, so try to remember these formulas. Okay students, so we will solve some problems. If x and y are the any two sets, if x and y are the two sets, such that the number of elements of the x union y equals to 50 elements, x has 28 elements and y has 32 elements, then how many elements does the x intersection y have? Right? So let us see. Let us solve this problem. Solution. What is given? Given that the total number of elements of the x union y is given 50 elements. The total number of elements of the set A, the set that is set X has 28 elements. Set Y has 32 elements. Set Y has 32 elements. So these are the given. But what we know? We know that n of A that is X intersection Y is equals to n of A X plus n of Y minus n of X union Y. So in the formula what we have written? In the formula these two terms are interchanged, or I can say that here I have interchanged these two terms. The formula is n of x union y equals to n of x plus n of y minus n of x intersection y. But what I want here is, the total number of elements, of x intersection y I want. Therefore, I took this unknown term to the left side and I took the known term to the right side. Now we can substitute the values. N of x is 28, n of y is 32, minus n of x union y is 50. Now you can add this. What is this? The addition of 28 plus 32 is 60. 60 minus 50, that is equals to 10. 60 minus 50 is 10, no doubt. Therefore, the total number of elements of the x intersection y is 10. The total number of elements of the x intersection y is 10. So in this way, one has to use the formulas. Okay, what is the actual formula? N of a union b equals to n of a plus n of b minus n of a intersection b. But I need here the intersection of the total number of elements of the intersection of two sets. I took the intersection to the left side, I sent the union to the right side, as I just adjusted as I want, right? So if I want n of the total number of elements of the one set, I take this to the left, or I keep it here, I send the remaining thing to the one side so that I can find the required number of elements of particular sets. Note on this solution. Okay students, so one more example we will solve. In a class of 35 students, there are totally 35 students are there in the class. 24 like to play the cricket. 24 students like to play the cricket. 24 students like to play the cricket. They want to play the cricket. 16 students want to play the football. 16 students want to play the football. And each student likes to play at least one of these two games. It means out of 35 students, at least every student will wish to play at least one of the games. Then how many students like to play both cricket and football? You have to find. Okay. So let us take what has been given. What is given? The total number of the students in a class. In a class means total number of the strength. So n of C union F, because C stands for cricket, F stands for football. Okay. So the total strength of the students is 35. What is given? 24 students like the cricket. So n of C is 25. 16 like to play the football. N of F is 16. Then what is need to find? How many students like to play both? Both means what? The n of C intersection F, cricket and football. We have to find the total number of the students who play cricket and football both, right? So what is the formula? We know that. What we know that? The n of C intersection F is equals to n of C plus n of F minus n of C union F. In fact, we have used the sets A and B, but here C stands for cricket, F stands for football. Therefore, I use the C and F. That doesn't matter. So substitute the values of n of C, n of F, and n of C union F here. So what is n of C? 25 students plays cricket. Football, 16 students play football. 35 students is the total number of the strength of the students of the class, total strength of the class. So add this 25 plus 16 is 40, 40 minus 35, so 5. So what we got? The total number of the students who play cricket and football both are 5 students. So the total number of the students who play cricket and football both is always 5 in the given condition. Note down this solution. Okay students, so let us start solving the problems in the exercise 1.6. Okay, we will solve all the problems in the exercise 1.6. First example, if x and y are any two sets, provided total number of elements of the set x is 17, n of x is 17, number of elements of the set y is 23, n of y is 23, and number of elements of the union of two sets x and y is 38, n of x union y is 38, and need to find the total number of the elements of the intersection of two sets x intersection y, that is n of x intersection y. Okay, so let's start. Solving. What is given? Solution. It is given to us, it is given that n of x is given is 70, n of y is given is 23, and also given that n of x intersection x union y is 23, and need to find n of x intersection y. We need to find what is x intersection, total number of elements of x intersection y. What we know? We know the formula that we know that n of x intersection y is equals to n of x plus n of y minus n of x union y. So according to this formula, according to the known values above, just substitute the values. N of x is here 17 plus n of y here is 23 minus n of x union y is 38. Sorry, this must be 38. So according to this, so this must be 38. So add these two. 17 plus 23 is 40. 40 minus 38. 40 minus 38 is 2. Therefore, the total number of the elements. Therefore, total number of the elements of x intersection y is 2. You would write at the end that the total number of the elements of x intersection y, n of x intersection y is 2. X intersection y is 2. Note down this solution. Okay, students. So let us solve the second example. If x and y are any two sets such that x union y has 18 elements, the union of two sets has 18 elements, x has 8 elements and y has 15 elements, then how many elements does x intersection y has? You have to find. Okay. So let us write down what has been given. So what is given? Solution. What is given? It is given to us that n of x union y is 18, n of x is given to be 8 and n of y is 15. N of y is 15 and need to find n of x intersection y, and need to find n of x intersection y. Okay. So we have a formula already. We know that n of x intersection y is equals to n of x plus n of y minus n of x union y. So according to this formula, let's substitute the above values. So what is n of x? N of x is 8, n of y is 15 minus n of x union y is 18. So 18 plus 5 is 23. 23 minus 18 is 5. Therefore the total number of the elements of x intersection y is 5. We will write that the total number of the elements of the x intersection y set is 5. Note down this solution. Okay, students. So the third example. In a group of 400 people, there are totally 400 people are there. 250 can speak Hindi. 250 people can speak Hindi. 250 people can speak Hindi. 200 people speak English, and we need to find how many people can speak both Hindi as well as the English. We have to find how many people will speak both Hindi as well as English. Okay. So let's solve this problem. What is given? It is given to us that the total number of the people who speak Hindi and English is 400. Is given to be 400. So the total number of the people who speak Hindi is 250. Total number of the people who speak English is 200. And need to find total number of the people who speak Hindi as well as the English. Hindi as well as the English. So what formula we know? We know that, so same formula we have to apply. We know that n of h intersection E, Hindi and English, is equals to n of h plus n of E minus n of h union E. N of h union E, where h stands for Hindi subject, E stands for English language. Okay. Okay, fine. So let us substitute. N of h is there 250. N of E is there 200 minus n of h union E is there 400. 400. You can substitute here. 250 plus 200 is 450. 450 minus 400 will give us a 50. So the total number of the people who speak Hindi and English is 50. They speak Hindi also, they speak English also. Hindi and English, Hindi or English, there is a difference, right? So the 50 people among this total 400, they speak both Hindi and English. They speak both Hindi and English. Therefore, n of H intersection E, Hindi and English, H intersection E is 50. Note down the solution. Okay students, so the fourth problem is, if S and T are any two sets, has that S has 21 elements, S has 21 elements, and T has 32 elements, and S intersection T has 11 elements, Then need to find what is the total number of elements of S union T sets. Okay, so let's take what has been given. What is given? Solution. So what are the given terms? What are the given things? Given is the number of elements of the S is 21, number of elements of the T set is 32, the number of elements of S intersection T is 11, and need to find number of elements of the S union T is how much? Okay, so as it is, we know that the formula n of S union T is equals to n of S plus n of T minus n of S intersection T. So just substitute the given things in this formula. N of S is 21 plus n of T is 32 minus n of S intersection T is 11. 21 plus 32 is 53. 53 minus 11 is 42. So the totally therefore n of S union T is 42. N of S union T is 42. 42 is the common elements of the S and T. 42 elements are common in both the sets S and T. Therefore, the S union T is 42. N of S union T is 42. Note down the solution. Okay students, so one more example you can see. In a group of 65 people, 40 like cricket, 40 people like the cricket, 10 like both cricket and the tennis. How many like tennis only? We have to find how many like the only tennis students, only tennis people, right? And no, but not the cricket. They must like only the tennis but not cricket. Only tennis, not cricket. And at the end, we have to find how many of them like the tennis. Okay, we have this given n of cricket, C for cricket, T for tennis, C union T is 65, n of C is 40, n of C intersection T is 10 is already given. So n of C union T equals to n of C plus n of T minus n of C intersection T. This is a known formula. What I don't know is n of T, so I keep the n of T to the left side, I adjusted the remaining term to the right side, which is n of C union T plus n of C intersection T. I send this to the right side, and I send n of C to the right side, that becomes n of C union T, n of C intersection T minus n of C. Substituting the above values, 65 plus 10 minus 40 will be 35. But what I want is, I want only the tennis but not the cricket. Only the tennis but not cricket. It means this T minus C. From the set of the people who play tennis, if I remove the set of the people who play cricket also, and from the common people who play cricket and tennis both, if I take these union, definitely I get the only people who play the tennis. I repeat again. From the set of the people who play cricket and tennis both, if I remove the set of the people, if I remove the number of people who play cricket from the tennis, and I take the common elements, I take the common people who play cricket and tennis both, and the union of these two will definitely give the T. Therefore, n of T minus C stands for only tennis but not cricket. Only tennis but not cricket. Only tennis but not cricket. Cricket has to be deleted from the tennis. Only tennis but not cricket is n of t minus n of t intersection C, which is 35. N of t is 35 here. What we got here is n of t is 35. N of t is 35. We just got n of t is 35. Substituting n of t and n of t intersection C is 35 minus 10, 25. 25 people only play. They only play cricket. Or play, or I can say like. I can say like tennis, but not cricket. You have to note on this. They only like the tennis, but not cricket. Note on this. So one more example is given in your textbook. Please solve this, and that will complete. That completes the sets. That completes the chapter sets. Okay. That completes the chapter sets. And thank you. Please practice all the problems in this chapter. That will helpful definitely for. I repeat again here the concept. So 1 marks question will be 1 compulsory. 2 marks question will be 1 compulsory, and 3 marks question will be 1 compulsory. 5 marks question will be compulsory 1. 5 plus 3 is 8 plus 2 10 plus 11. So totally 11 marks concept this is. Minimum 11 marks are going to be appear. The 11 marks questions are going to be appear in the exam. So please practice these problems. Definitely they are going to help you. Thank you.